In this video, you will learn about the distance formula. First, let's start by where we could derive the distance formula with points. So if I were to look at this example, I could say that the length of segment AB, if I were to use the boxes here, is 1, 2, 3, 4. So the length of AB is 4 segments, or 4 units, and the length of BC is 3 boxes with a scale of 1, so my length of BC is 3. Now, if I want to find this missing side, what I know is this is a right triangle. So I could use Pythagorean theorem, which states that a squared plus b squared equals c squared, given that if I have a right triangle, c is the side across from the right angle, and those two sides are a and b. So since x is the side across the right angle, I could say 3 squared plus 4 squared equals x squared. So 9 plus 16 is x squared. So 25 is x squared. Take the square root of both sides, so you get x is equal to 5. In this video, you'll learn how to find the distance between two points in the coordinate plane using what's called the distance formula. The distance formula states that the distance between 2 points, x1, y1, and x2, y2, is given in this long formula, the square root of x2 minus x1 squared plus y2 minus y1 squared. Please make sure that you write down this formula so you have this in your notes. Now let's learn how we could derive the distance formula. What we know is if I want to find the distance between 2 points for each side length, I could subtract. So like let's say, for example, I were given that this point was at -3, comma, -1.5, and this was at 4, comma, -1.5. We all know that realistically to get from this red point to the black point is 7 boxes. And what I could do to get there is I could say I could subtract the x value. So I could say 4 minus -3 gives us 7. So my side length is 7. The same idea exists for this other side. So let's say I say that this point was at 4, comma, 4.5. If I want to find the distance between these 2 points, I'm going to subtract. So it's 4.5 minus -1.5, which would give us a value of 4.5 plus 1.5, which becomes a value of 6. Now I could find this missing side using Pythagorean theorem. So if I call this d, I could say 6 squared plus 7 squared equals d squared. So this becomes 36 plus 49 is d squared. And if I do 36 plus 49, gives you 85 equals d squared, and I could take the square root, so I get the distance is 85 is d. Now let's say I don't have numbers. Let's say I just use my points. So instead of saying what I have here, and before we said I just subtract the two x values, so I say x2 minus x1. So now let's call this x2 minus x1. The same thing for the y's. We know that to get my length of this other side here, I could say let's subtract my two y values. So y2 minus y1. I'm going to call my last missing side d. So now if I use my Pythagorean theorem, I have one side is x2 minus x1 squared, and then it's plus my other side is y2 minus y1 squared, and it all equals the other side, so I can say it's d squared. Now to finish solving, if I want to get just the distance, I could say let's take the square root of both sides. This becomes the square root of x2 minus x1 squared plus y2 minus y1 squared is all equal to d, which we'll notice is the distance formula. Now, you'll never be expected to come up with this on your own. However, it's good to understand how the distance formula connects to our Pythagorean theorem. All right, two important things to note is when we apply the distance formula, we're going to get radical answers. If the radical is a perfect square, simplify to the whole number. So for example, if I take the square root of 64 and I type it into the calculator, it becomes 8. So your final answer here is going to be 8. If it is not a perfect square, you're going to leave it as an unsimplified radical. So if I took the square root of 20, for example, and I typed it in, it becomes 4.472. It keeps going. Because this doesn't simplify, we're going to leave my final answer just as the square root of 20. There is a way to simplify radicals, however, we're going to deal with that later in the year. In this example, if I wanted to find the distance between -6, -2, and 0, 6, and my formula is x2 minus x1 squared plus y2 minus y1 squared. First, we need to type which points I want to call x1, y1, and x2, y2. And again, it doesn't matter as long as I'm consistent with it. Then if I fill in my formula, it's going to be the square root of x2, which is 0, minus x1, which is -6 squared, plus y2, which is 6, minus y1, which is -2 squared. If I continue to simplify, 0 minus -6 becomes 0 plus 6, so it's just 6 squared. And 6 minus -2 is 6 plus 2, which becomes 8 squared. So the square 36, or 6 squared is 36, and 8 squared is 64. So this becomes the square root of 100. When I type 100 into the calculator, it just becomes, the square root of 100 is just 10. Again, if I call the first points x1, y1, and the second one's x2, y2, say the distance formula equals the square root of x2 minus x1 squared plus y2 minus y1 squared. So if I fill in x2 is -4, minus x1 is 1, and y2 is 4, minus y1 is -3. So if I keep going, -4 minus 1 is -5 squared, and 4 minus -3 becomes 7 squared. This becomes the square root of 25 plus 49. If I do 25 plus 49, it gives me value of 74. Now if I type the square root of 74 into the calculator, it becomes 8.6, so I leave my final answer as this. So if I were to apply this to an example, let's say I choose to call my points x1, y1, and x2, y2, and I'm filling into the formula. So it's x2 minus x1 squared plus y2 minus y1 squared. So I could fill in that the value of x2 is -4, minus the value of x1 is 5, plus the value of y2 is -1, minus the value of y1 is 2. If I simplify, this becomes the square root of -9 squared plus the square root of -3 squared. So this becomes the square root of 81 plus 9. When I square a negative number, negative times a negative becomes positive. So it becomes the square root of 90. Now, when I take the square root of 90 into a calculator, it becomes 9.4868, and it keeps going. Since this is not a whole number, we're going to leave our final answer as just being the square root of 90. Now, some of you may ask, does it matter which point I call x1, y1, and x2, y2? And technically speaking, it shouldn't matter. If I look at the example, so let's say I call 5, 2, x1, y1, and -4, -1, x2, y2. When I plug into the formula, it'll look like this. If I keep going, it becomes -9 squared plus -3 squared. And we want to square a negative number, it becomes positive. So it becomes 81 plus 9, which gives us the square root of 90. If I flipped it and I call x 5, 2, x2, y2, and -4, -1, x1, y1, if I plug in the formula, it'll look like this. When I simplify, 9 squared plus 3 squared becomes 81 plus 9. They still give us the square root of 90. So what we should see here is that regardless of which one I call x1, y1, and x2, y2, we get the same answer.